8.5.
Wow.
Quadratic functions.
Not on your turn.
Yeah. Quadratic functions. Now the book only deals with one type of quadratic function, so I have to make sure I keep focus because there's like 2 different styles, and they only stick with one style, and they don't prove anything about it. So a quadratic function. Get back into function notation. Remember f of x? F is not a variable. F is like franc. And it's equal to ax squared plus bx plus c. And we have to make sure that a is not equal to 0. If a is equal to 0, we're not talking about a quadratic function anymore. We're talking about either a linear or a constant. And both of them are kind of trivial. So we have to keep that a not equal to 0, so we have that x squared term. Now, we're going to be doing graphing with this stuff. Simplistic, nothing really hard. So a general picture of a quadratic looks something like this. This is called a parabola, or a quadratic. Personally, I like calling it a parabola. It just sounds neater.
The guy's name?
Parabola? No, it's just something they called it. There's parabola, hyperbola, circles, ellipses, hyperbolas. This is just one of the, it's called a conic section graph. All right, so what does this graph have in common with all the graphs we've dealt with before? Well, it has this point right here. This one's called? That is not an X-Intercept.
Why?
Again, you're going to go through every vocabulary word that you can think of.
L-axis.
This is the Y-Intercept. All right. Then there's these 2 points down here, and both of these are called X-Intercepts. Now, there is a possibility that there are not 2 of these X-Intercepts. There's something called a translation, where you can move the graph anywhere around. If I move this graph really high, how many X-intercepts is it going to have?
None.
None. And if I bring it down just so that lowest point touches the x-axis, it would only have 1. And if I sink it down, it'll have 2. So X-intercepts could be 0, 1, or 2. The most common one, of course, is 2, having 2 X-intercepts. But that's not always the case. And probably the most important point on the graph is this lowest point. And if you flip it upside down, it would be the highest point. This is called the vertex. The vertex of the parabola. It is either the lowest point when it's positive x squared, or the highest point if it's negative x squared. It would be flipped upside down. Now there is a line that goes right down the middle of this graph. It goes right through the vertex, and the graph reflects over it. You know, remember reflections in like first grade? Does the letter A have a line of reflection? Yeah, it goes straight down the middle. Whatever happened on the left also happens on the right. Does B have a line of reflection? Yeah, but this one is a horizontal line, not a vertical line. This also has a line of reflection, and then it is a vertical line. So whatever happens on the left of this line also happens on the right. So we have this Y-intercept up here all by himself. So there must be a corresponding point on the other side. And this is the coolest part. If this distance is D, and we go the same distance on the other side, we find this new point. So I'm going to call this a reflected Y-intercept. So no matter what, if it has X-intercepts or doesn't have X-intercepts, you're guaranteed at least 3 points. If you have X-intercepts, you start increasing it to 4 or 5. I call this the 5-point method, where you're finding the intercepts, you're finding the vertex, you're finding the axis of symmetry, and a reflected point. So let's do a boring one out of the book. Oh, there is one other thing I have to teach you. I can't prove it's true, but if you want to find the vertex, this is a little star thing, this is something you have to memorize. You're going to say f of, how do I want to call it? Let's call it v for vertex. No, not f of v. F of negative b over 2a is the vertex. What's neat about writing it this way is this is actually a coordinate. The x-coordinate is?
Negative b.
Close, no scar. Say the whole thing.
Negative b over 2a.
Negative b over 2a. And the y-coordinate is?
F.
F of negative b over 2a. Back to function notation. The x is what goes inside. The evaluation of it is the entire thing. So this becomes our vertex. Negative b over 2a is the formula you need to memorize. So if you just want to memorize it as a little piece, it's x equals negative b over 2a. That actually finds the axis of symmetry, the line that goes vertically through the vertex. All right. Let's do a simple one. Number 12. Well, let's go a little further back. Number 6. This one isn't graphing, it just says find the coordinates of the vertex, y-intercept, x-intercepts. And that's about it. So p of x is equal to 2x squared plus 4x plus 1. How do you find y-intercepts? How do you find the y-intercept of a graph? Y-intercept of a graph? Where it crosses the y-axis?
You look to the right of the x.
Yeah, but if you're on the y-axis, what did we know?
X is equal to 0.
X is equal to 0. So to find a y-intercept, you're going to let x equal 0. This goes way back, linear equations and graphing. So to find a y-intercept, you're going to let x equal to 0, which is the same thing as doing p of 0. When you're saying x is equal to 0, that p of x becomes p of 0. So p of 0 is going to equal 2 times 0 squared plus 4 times 0 plus 1.
Which is 1.
Which is 1, because the zeros will cancel those out, or 0 them out, and you get 1. That's a coordinate. So the y-intercept has a coordinate of, what's x?
0.
Y?
1.
And we get this y-intercept of 0, 1. Right. How about x-intercepts? How do you find an x-intercept?
Let y equal 0.
Let y equals 0. Because if you're on the y or x-axis, the y-coordinate has to be equal to 0. So, go back to your original function. Where's y? In this thing, where is y? I don't see a y. P of x. So I'm going to replace p of x with 0. So you're going to get 0 equals 2x squared plus 4x plus 1. How do you solve that equation?
Quadratic formula.
Quadratic formula. Because there are no factors of 2 that add up to 4. 2 and 1 just add up to 3. So quadratic formula, or if you feel like it, completing the square.
So anytime that if it adds up in the middle, if 2 added up to 4, we just solve it regularly.
Yeah, you factor it. It makes it a lot easier.
I mean, even if you gave us one that said solve quadratic formula.
Outside of the ones where I ask you to solve by completing the square, solve by perfect square, solve by quadratic formula, outside of that, you can do it any which way you want. I highly suggest you always pick the easiest method. But if you always go quadratic formula, you're going to be sitting there doing a lot of calculations sometimes that aren't necessary. Plus, you make silly mistakes like forgetting the plus or minus. But this one definitely doesn't factor because factors of 3 do not, or I'm sorry, factors of 2 do not add up to 4. So quadratic formula says x is equal to negative b plus or minus the square root of b squared minus 4ac. I got room over here. All over 2a. You could, but if you're going to complete the square, you'd have to divide everybody by 2. And then half of 2 is 1 squared. You could do it. It's actually not that hard. Do you want me to practice it?
Oh, no, it's okay.
We'll do it on the next one. That doesn't work out really well. What's b equal to in this case? 4. 4. B again is 4. A?
2.
C?
1.
And then A again is 2. This one's just nice because you don't have to think about it. You just throw it at it and let it do its work. X is equal to negative 4 plus or minus the square root of 4 squared, 16 minus 8.
8.
This is 8. All over 4. Ooh, square root of 8. That's not possible. What can I do with square root of 8? Pull out of 2. So this becomes x equals negative 4 plus or minus 2 square roots of 2, all divided by 4. I can't leave that.
Reduce.
Do I just take the 4s and be done with them? Yeah, you have to do everybody. So what is the common factor across all 3 terms? 2. So divide them all by 2 and you get negative 2 plus or minus square roots of 2 divided by 2. Problem. The book wants it in decimals and so do I. So you can't say, well, there's my answer because that tells you absolutely nothing. Because I don't know where to put these as coordinates on a piece of graph paper. So I need to know what negative 2 plus the square root of 2 divided by 2 is and negative 2 minus the square root of 2 divided by 2. Yes, you have to get out here.
They told me it would be a calculator so much for this class.
Just to the nearest 10th. Just to the nearest 10th. Negative 0.3. So when I write it, it's a X-Intercept, and I know Y is equal to 0. So negative 0.3 comma 0. And the minus 1. Negative 1.7. Make sure you can get these answers. Comma 0. So these would be your X-intercepts. And this is your Y-intercept. Oh yeah, we're going to do a bunch of these. Everybody get those 2 answers?
Yeah.
Why not? Oh, you have 2 squares of 2. It's just square root of 2. See? Square root of 2.
So how do we punch that in the calculator?
I would highly suggest you type in negative 2 plus square root of 2, hit equals. Get an answer, then divide by 2. Because if you try to type it all in at once, there's too many things going on, a lot of missing parentheses. So it's just easier to type in the top, divide by 2. Did you get it?
0.3, yeah.
Yeah, negative 0.3. All right, the last piece that we have to find on this is vertex. To find the vertex, we have to use this formula right here. And it's not too hard. Negative b over 2a. It actually takes pieces that you put into the quadratic formula. The negative 4 over 2 times 2 over here. So x equals negative b over 2a. Ooh, I don't want an a there. Is going to become, well, b was 4, a was 2. Negative 4 over 4, better known as? Negative 1. So the axis of symmetry has an equation of x equals negative 1. It's that vertical line that actually goes through x equals negative 1. And the vertex is going to lie on this axis of symmetry. So the next step is this. If I ever tell you what x is equal to, and we're talking about functions, you better go find the function, y. If I give you x, you go looking for y. If I give you y, you go looking for x. It's pretty much all the functions do. So we go back to the original function, p, and we're going to substitute in -1. That'll tell us the y coordinate. So let's see here. This is 2 times something squared plus 4 times something plus 1. And the something is? -1. -1 squared is? 1. So that'll just give us 2. Minus 4 plus 1.
-1.
So our other coordinate is -1. How boring. So the vertex, and I'm going to label it with a V, the vertex is -1, -1. And those are the 3 most important pieces of information about quadratics. X-intercepts, Y-intercepts, vertex, well, and actually axis of symmetry comes into play. Let's do one more like that. Then Wednesday I'll show you how to graph them. Maybe we can graph a little bit today. What looks nice? Let me make up one. Yeah, it's going to get ugly. Let's see. F of x is equal to 2x squared minus 6x plus
94.
1. 94. That'd be horrible. So let's go do the same thing. Find the y-intercept, find the x-intercept, find the vertex. And might as well just do it in the same order. Y-intercept first. It's actually the easiest piece. And sometimes by doing the easiest piece first, you start getting into a flow. It wakes up your brain a little bit. If you're looking for a y-intercept, what do?
Let x equal 0.
Let x equal 0. So we get f of 0 is equal to 2 times 0 squared minus 6 times 0 plus 1.
1
is 1. So we're going to get the coordinate x is equal to 0, y is equal to 1. X-intercept. Define an x-intercept. Set the whole equation equal to 0. In other words, f of x or y equal to 0. So this becomes 0 equals 2x squared minus 6x plus 1. I set this up so it doesn't factor, but I do want to practice something other than the quadratic formula, so we're going to complete the square. Might as well, the test is coming. So how do I complete the square on this?
Half of 6 is 3.
Divide everything by 2. That lead coefficient has to be 1. So everybody gets divided by 2. Both sides of the equation to be proper. Then you can start doing your completing the square stuff. So this is, do you want to flip the order of it so the 0 is on the right? Or do you don't mind it this way? Okay. So leave it alone. 0 equals x squared minus 3x plus a half. All right, now what? Move the half to the other side. Give myself some room here. Let's bring it up here. So we're going to get -1/2 is equal to x squared minus 3x. And I don't even have to leave a space, it's automatically there. Now what?
Why did we move that -1/2 over 4?
When you're completing the square, the number, the constant, goes to the other side of the equation. That's why I said, do you want me to reverse it? Because then you would start seeing it as a normal pattern. All right, how do I complete the square? Half of -3 is? -3 over 2. Squared becomes?
9 over 4.
A positive 9 over 4. If you add it to the right,
Add it to the left.
you add it to the left. If you have to put a little plus sign there to remind yourself that it's positive. Oh, okay.
Why did you show up? I mean, what was the point? There's like 3 minutes left.
Okay. The hard part. Dedication. Oh, you have a loose term of definition on that one. Common denominator here is?
4.
So we're going to multiply top and bottom by 2. So this is 9 fourths minus 2 fourths, better known as
7 fourths.
7 fourths. So this side is 7 fourths is equal to, the other side is a perfect square, x minus 3 halves. And how do I solve this equation? Square root both sides. 7 fourths becomes plus or minus the square root of 7 all over 2 is equal to x minus 3 halves. I'm going to move the x to the other side. It's freaking me out that it's on the right. I don't know what's going on. So x is equal to. Now, the cool thing is there's a common denominator here, which is 2. What goes first? Positive 3 plus or minus square root of 7. Yay! So, completing the square, quadratic formula, they both take about the same amount of time. Completing the square is actually faster if you practice it a lot. It's much faster than quadratic formula sometimes. Especially if that middle term is even. Okay, I need decimals. If you can text on your little cell phone, you can push little buttons on my calculators. Oh.
You sound pretty
Yes, I know.
Me.
hard.
Well, I am too. 2.8. So one of them is 2.8, so I'm going to write it as 2.8 comma 2.8 comma 0. We have to go way back to the beginning. Y is equal to 0. And the other one is 0.18, so 0.2. If you round it to the nearest 10. So 0.2 comma 0. The only reason that you round it to the nearest tenth is you're going to be graphing these, and there's no way to graph 100th. Tenths are kind of easy if it, you can kind of guesstimate where it belongs, but 100th position is useless. All right, so far we have the Y-intercept and the X-intercept. The X-intercept you'll find is the hardest part of this. The rest of it is, not too bad. How do I find the vertex? Negative b over 2a is the formula. So, vertex. X equals negative b over 2a. What's b?
3.
B is not 3.
Oh, top,
You got to go
6.
back to the original function.
Negative 6.
Yeah, don't ever use one where you solved it or set it equal to 0 and simplified it into something else. You have to go back to the original function. So b is,
Won't be positive 6.
well, it'll be negative 6. Over 2 times a is 2. So this becomes positive 6 over 4, better known as
3 halves.
3 halves. That's kind of cool. All right, so if x is equal to 3 halves, how do I find y? Go back to the original function and plug it in. So we're going to go f of something is equal to 2 times something squared minus 6 times something plus 1. And that something is 3 halves. So we're trying to find f of 3 halves. We plug it into our function. Horrible. Thank God for calculators. Type it in exactly the way it looks. 2 parentheses 3 divided by 2 parentheses squared minus 6 parentheses 3 divided by 2 parentheses plus 1. It equals. What's it coming up here? Seriously.
3 over 2, 2 times 2 over 1 is 6 over 2 is 3 squared is 9, and 6 will be 18 over, negative 18 over 2 will be negative 9.
Over 2.
Oh, negative 3.5.
What is it?
I got that's what I got.
Negative 3.5. You
If that's
lost
what
it.
we want.
This becomes 9 fourths times 2, which is 18 fourths, minus 18 halves.
Oh, yeah, I didn't have that.
Yeah, but 18 fourths minus 18 halves is negative 9 fourths. And negative 9 fourths plus 1. It gets all funky. But you got what, negative 3.5? Negative 3.5. Also known as 10 halves. 10 halves?
Sounds good.
No. That's not good. 7 halves. 7 halves. So this, if you want to write it, could be 3 halves. See, this one's written as 3 halves. It's better to write this one as 7 halves. Or you can write this as 1.5 comma negative 3.5. You want your coordinates to correspond. If one's a decimal, make both of them a decimal. If one's a fraction, make both of them a fraction. Both of them are acceptable for me. I'm not sure how the computer is going to treat it. So those would be your vertex. Highest and or lowest point on the graph. Oh, we need to do one more. Do we have time? Not much.
I think we should talk about the party we're gonna have.
Party?
Yeah, we bring the cookies, bring the Kool-Aid.
Who's having a party?
What stuff happened the last game, so we're gonna party.
No. I don't do parties. I'm antisocial.
Come on, Scrooge.
I am the Scrooge and the Grinch all rolled into one. Ebenezer, yes. How about this one? G of x is equal to, let's really make it horrible. 4 minus 6x minus x squared. Why is this one different?
Multiply everything by -1.
If I multiply by everything by -1, I'm back to something normal looking. So that negative x squared makes it a little odd. Plus it's out of order, but that's okay. And what I just want to do is show you how to find all the information quickly. So first up, y-intercept. How do I find it? Set x equal to 0. If you set x equal to 0, you're going to get g of 0 is equal to, tell me the answer, 4. Anything with an x is going to go poof. Be careful of that if there's any grouping terms. It doesn't just go poof if there's grouping. Parentheses, perfect squares, things like that. X-intercepts. Okay. To find the x-intercept, set y equal to 0, set the whole function equal to 0. So you're going to get 0 equals 4 minus 6x minus x squared. How do you want to solve it? See, the original function, you can't manipulate it too much. You can put it in order and that's about it. But if you're solving for a quadratic equation, you can manipulate it any legal way. What would you do first?
A squared can be negative.
I don't like it being negative. It can be negative. I just don't like it being negative. So what would you do? Just change all the signs and change its order. So you could rewrite this as 0 equals positive x squared, positive 6x, minus 4. But be careful. I just changed it for the equation purposes. That changes nothing about the functions. So if you're going to go and graph this thing, you can't use the equation to do it. You have to go back to the original function. Most mistakes that are made are going back to this step and plugging in the information into this step and getting the answer wrong because these two things are different. G of x is not what I just wrote. This is something different. All right, how do you want to solve it? Really? See, I just look at this and say complete the square. Factors of 4 do not subtract up to 6. But I think completing the square works real well because the middle number is even. It's even. So,
Using my phone.
what are you doing?
It failed.
It fell apart. So what would you do first if you're going to complete the square?
Half it.
No.
Huh?
What would you do first if you're going to complete the square? Move the 4. It's in the way.
That's what I said.
What life. So you get 4 equals x squared plus 6x. Then what?
Half it.
Half of 6.
3.
Square it.
9.
Add 9 to both sides. So we get 13 is equal to
X plus 3 squared.
x plus 3 all squared. And then how do you solve it?
Square root.
Square root. So we get X plus 3 is equal to
Square root of 13.
plus or minus, yeah, that thing, square roots of 13, and then move the 3 over. So you get x equals negative 3 plus or minus the square root of 13. Much quicker than the quadratic formula.
Yep.
A lot less calculations too. But now you have to type it in your calculator and come up with the two coordinates. So negative 3 plus the square root of 13.
You gotta do this still.
I know, it's horrible.
0.6.
0.6. So we're going to get 0.6 comma 0. And the other one would be negative 3 minus the square root of 13.
Negative 6.6.
What is it?
Negative 6.6.
Negative 6.6.
Yeah. That's what you got.
I thought you said nope. All right, and then how do I find the vertex? Now, where do I get the negative b in the 2a?
From the original problem.
From the original problem. Don't be looking at the X-intercept problem. Go back to the original problem. B here is negative 6. A is negative 1. So you go x equals negative b over 2a. Ah, did it again. Over 2 something. And b is negative 6 and a is negative 1. So negative 6, negative 1. So we get 6 over negative 2, better known as negative 3. And to find the vertex completely, that's just the axis symmetry part of it. Plug it into where?
It's just 3, not negative 3.
Negative
no,
negative
you're
6
right,
is
you're right.
positive 6. Positive 6 divided by negative
Right.
2 is negative 3. So what do I do with the negative 3? Plug it back into the original quadratic. So g of negative 3 equals 4 times minus 6 times negative 3 minus negative 3 all squared. Positive 9, negative 9, positive 18, positive 9 plus 4, 13. I think. I'm guessing. No, don't guess it's right because I'm horrible with calculations. Positive 9, negative 9, positive 18, positive 9, plus 4 is 13. Any confirmation?
Yeah. That's what I got.
That's a, yeah.
Yeah,
I don't trust you at all. So the coordinate for the vertex is negative 3, 13. So X-intercepts, Y-intercept, well, I never wrote it out, 0, 4, Y-intercept, X-intercepts, and vertex.
Well, I'll forget to do all this.
But that's the thing, if you practice it, how do you find a Y-intercept?
Put 0 for x.
Set x equal to 0, so this becomes g evaluated at 0 is
That's
equal
0,
to...
1 for the y.
Yeah, can I go through it? Thanks. And then you plug in your 0, and the two terms with the 0 go, and you're left with 1. So that's an easy one. 0, 1 is your y-intercept. Right. How do you find an x-intercept?
You do that problem with the b over negative b over 2a.
X-intercept.
That's the
Y
vertex.
is right.
The vertex.
Well, y is equal to 0. Also known as g of x is equal to 0. So you set the whole thing equal to 0, and you get 3x squared minus 5x plus 1 is equal to 0. How do you solve this equation?
Either you can, well, no.
Try factoring, number 1.
Or you can do the quadratic formula.
You could try completing the square, but leave coefficient of 3, that throws it out. So yeah, quadratic formula. So x equals negative b plus or minus the square root of b squared. This is where people are screwing up. They're not putting parentheses here and they're getting weird answers. Make sure whatever this number is, you put it in parentheses, and this one also. They're two of the most important ones. And then you have negative 4 times a times c, all divided by 2a. I highly suggest you write your quadratic formula like this, then plug your numbers in. That way you don't make sign mistakes and some other weird things. So negative b plus or minus square root of b squared minus 4ac all over 2a. What's b in this case?
-5.
Negative 5 goes here, but it also goes here. What's a?
3,
3, C, 1, A,
3.
3. Now, since we're trying to come up with x-intercepts and we're not going to graph it yet, I just want the radical expression, the exact answer. So this is going to be x is equal to negative, negative, positive, plus or minus the square root of, this is positive 25 minus 12. 13? 13. So this becomes the square root of 13. I don't know why I made the bar so long, but yeah. All divided by 6. So your answer for your x-intercepts, I usually put the small one first, so it would be 5 minus the square root of 13 divided by 6. And the other one's going to be 5 plus the square root of 13 divided by 6. Oh, dang it. Scribble this out. I'm thinking, I was thinking of two things at once. I was writing the solutions to the equation, but I want to write them as coordinates. The coordinates are 5 minus the square root of 13 over 6, comma, 0, and 5 plus the square root of 13 over 6, comma, 0. If you just list them out with a comma separating them, really should have the squiggly lines on parentheses. That would be the solutions to this equation. What we're looking for is x-intercepts of the function. All right. Last step. I'll put it over here. It'll fit. Y-intercept, x-intercept. Vertex. I didn't hear you whispering back there. Vertex. How do I find a vertex? X equals negative b over 2a. B in this case is?
Negative 5.
So it would be negative, negative 5 over 2 times a, and a is?
6.
Well, a is 3. Jump the answers. So you get positive 5 over 6. So 5, 6. Perfectly fine. But if I tell you what x is equal to, you better go looking for? Oh my gosh, we're dealing with a function. I said it's 2 variables. One of them is x, the other one is y. If I tell you what x is, you better go looking for y. If I tell you what y is, you better go looking for x. I mean, that's how these all work. Even when we're finding x and y intercepts, I tell you what x is equal to, you go looking for what y is equal to. X intercepts, I tell you what y is equal to, and you go looking for what x equals to. So here you have this x equals 5, 6, so you have to go and plug it into the function. So you get g evaluated at 5, 6 is equal to 3 times something squared minus 5 times something plus 1.
Is your computer working?
You mean like wirelessly? I don't use it in here wirelessly.
Oh,
Now I'm curious. Now, how you drove together? So we put 5, 6 in here, 5, 6 in here, and this becomes 25, 36 times 3, so that would be 75, 36, minus 25, 6, plus 1. Common denominator?
36.
36, so that would be 75, 36, minus 6 times 25, it's 150. So 150, 36, and then obviously 36 over 36. Of course, you can always just type this in your calculator and use your fraction button. Let's see, 75 minus 150 is 75. So it'd be negative 75 plus 36, which is...
Let me get a decimal.
This number is a fraction. Your answer is going to be in fraction form.
Yes.
No decimal. You can't mix fractions and decimals. You have a calculator. You know there's a little ABC button on there? If you type in 3 parentheses 5 ABC 6 parentheses squared, and then just use the ABC every time you see divide, you'll get a fraction as an answer. But I'm probably going to get it quicker than you. Negative 75 plus 36, borrow 6, 15, 9, 39. So the answer is going to be negative 39, 36, also known as negative 13 over 12. Yay! So the vertex of this thing is going to have a coordinate of x equals 5, 6, y equals negative 13, 12. Is that what you got in your calculator?
1,
Okay, now hit
One
second
over one.
ABC. Hit second ABC.
second.
Second ABC. It equals
Mm-hmm.
negative 13. Oh.
Yeah.
You know, these calculators are actually pretty cool if you learn how to use them. All right, so that's X-intercept, Y-intercept, vertex. As hard as it gets. I mean, that's 40.
We at the very end, we got to plug the 5, 6 back in and get that answer.
That's the thing. This doesn't tell you what the vertex is. It just tells you an x-coordinate. This is graphing. You need an x-coordinate and a y-coordinate, so you have to go looking for the y. So this is the y way down here, the negative 13 12s. All right.
The vertex was that highest peak of the point.
It's either the highest point or the lowest point. In this case, this one is the lowest because it's positive x squared, so the curve is upwards. It's kind of called concave up. If you put a negative x squared, it turns the whole thing upside down and it's concave down, and you're talking about maximum. All right, so let's continue 8.5. Well, actually, that is 8.5. Why did I say 8.4? This is 8.5. All right, 8.5, the rest of it. Or you can call it the end. The last thing I'm going to teach you.
School.
Check this grade. The last thing. We can have a party now. All right, that's over. The last part has two parts to it. Graphing, and of course, word problems. So we'll deal with the graphing first. And actually, we've already done most of the graphing. So what I want to do is, let's take this one and come up. Does it work really well? Actually, it does. I just need decimal answers in a second. So if we're going to graph that, it's better to actually draw the graph not on graph paper because you can scale it any which way you need it to be. Like if the numbers are really big, you can make this like really small and have these go from positive 10 to negative 10. The numbers here are relatively small. 0, 1, 5, 6, negative 13, 12, that's like negative 1. Where's my other points? These two. And square root of 13 is a little bit under 4, a little bit under 4. So that's like 5 minus 4 divided by 6 and 5 plus 4 divided by 6. So they're all relatively small, so I'm just going to go 5. I always like graphing. Nobody else does. All right, and then just put your information into the graph. What's the y-intercept of that thing?
It is
Where's the y-intercept of that graph, of that function? 0, 1. So to plot 0, 1, is it here? No. Make sure 0, 1 is a y-intercept, so it has to go on the y-axis. The other point we could plot, not nicely, but not a point, but we can at least get our axis of symmetry in. This is being the axis of symmetry, 5, 6, which is a little bit less than positive 1. So 5, 6 would be like here. So we get this vertical line that's going to split our parabolas in half. So the graph is going to reflect over this dotted line. Now on this dotted line has to go the vertex. And the vertex in this case is, where is it?
5, 6.
There it is. 5, 6, negative 13 12ths. Negative 13 12ths is like negative 1. Really close, a little bit lower than negative 1. So we're going to get this point right about here. And this is going to be our vertex. And it has to go on the axis of symmetry. It can't go anywhere else. So far we have a y-intercept, we have this vertex. We have two x-intercepts. There's a problem with them though. I don't know how to graph 5 minus square root of 13 divided by 6. So you're going to need your calculator to come up with an approximate decimal answer.
All right, then.
So I would suggest type in the top line first, hit equals, then divide by 6. What is it? 0.2. So this is really close to, approximately, 0.2 comma 0. And 5 plus square root of 13 divided by 6? 1.4. So this is really close to 1.4 comma 0. Now graphing-wise, that's about as accurate as you're going to get, because you're going to be way off one way or the other, decimally. So point 2 is right about here. It's really close to the origin. And 1.4 would be right about here, almost halfway. I should have probably zoomed up on this picture a little bit more. So there's 5 in each direction, maybe just 3, but you get the idea. Now there's one more point you can plot, and this is the one you have to remember. Remember, everything that happens on the left of the axis of symmetry also happens on the right. The vertex reflects onto itself. The X-intercepts reflect onto each other. So the only thing that's missing a reflection is the Y-intercept. So to find the coordinate, it's real easy. How far is it from here to the axis of symmetry?
5, 6.
5, 6. So all you have to do is move another 5, 6 over to come up with this new point over here. So what's 5, 6 plus 5, 6?
10, 6.
10, 6, better known as?
1 and 4, 6.
10, 6. Reduce the fraction.
5/3.
5/3. 5/3, right? So this has a coordinate of 5/3, comma, how high up are we?
1.
1. And then we have a nice picture for our parabola. Comes down, goes through these points. This is the lowest point it goes through, and then it goes up. And you get that. Isn't that neat?
Oh, yeah.
Alright, do one more. Cool beans. Just one, yeah. You can graph one, you can graph any of them. Because they all have the same properties. Well, except for one thing. They might not have X-intercepts, and then you only get the vertex, the Y-intercept, and the Y-reflected point.
Well, the vertex sometimes doesn't have X-intercepts.
Yeah. Well, no, it would have one X-intercept if it's on the X-axis. If you have a point here, it would bounce off the X-axis. And then you'd have the you'd have a vertex as an X-intercept, and then just the Y and the Y reflection. All right. Let's make up an easier one.
You got lost me. Smart talk.
Smart talk. Graph f of x is equal to negative x squared plus 4x minus 5. I have no idea what this looks like. Well, I have a general idea of what it looks like, but I'm not sure how messy it's going to get. All right, so let's just go through all of the steps. Step 1, find the x-intercepts. Or no, easier one, y-intercepts. So if we find a y-intercept, what do?
Put 0 in.
Put 0 in for
X.
x. So we get f of 0 is equal to negative 5. Anything with an x is just going to become an identity and it goes away. Okay. So this is a coordinate. X is equal to 0, y is equal to negative 5. Put a box around that because that's one thing I'm going to plot. Okay. The next piece is x-intercept. To find an x-intercept,
Set to 0.
set the entire function equal to 0, y equal to 0, or f of x is equal to 0. If you do that, we get 0 is equal to negative x squared. Don't lose that negative. Plus 4x minus 5. How do you want to solve this equation?
Get a factor.
You can try to factor, but there's a problem. That negative right here. You cannot complete the square with a negative in front, and you cannot factor with a negative in front, or it actually makes it a lot harder. So one of the things you want to do is go through and change all the signs. Now, after you do that, you're not talking about the original function again, so don't ever use the equation we're going to come up with for any further answers than just the x-intercept. So this becomes 0 equals x squared minus 4x plus 5. Are there factors of 5 that add up to 4? No. If you say 5 and 1, I'll be really upset because 5 plus 1 adds up to 6. So we could complete the square if you want to practice that. This one works really well for completing the square. Why? Because 4 is even. If this was 3, I'd probably just jump into the quadratic formula and be done with it. So I'm going to rearrange it. X squared minus 4x, leave a space, is equal to
-5.
-5, because that's going to get moved to the other side. All right? Half of 4? -2.
-2.
Square it. +4. So we're going to add 4 to both sides. Add 4 here. Add 4 here. The left-hand side becomes
X minus 2 squared.
x minus 2 all squared is equal to
-1.
negative. Uh-oh. Do you have to go any further?
No.
No. Why? Because if I square root both sides, the square root of -1 is
1.
I. See, if you square root, you're going to get x minus 2 is equal to plus or minus I. And just because we have this I here means that we cannot find any. There's no x-intercepts because you can't plot I on a real coordinate system. So this means no x-intercepts. There's not a 1. So either this graph is totally above the x-axis or this graph is totally below the x-axis, depending on which way it's facing. All right, what else can I find?
Vertex.
The vertex. And that has a neat little formula, -b over 2a. So let's see here, vertex. So you said x equal to -b over 2a. So that becomes negative something over 2 times something. What's b in this case?
4.
4. What's a?
-1.
-1. Remember, you have to go back to the original function. Don't go looking at that quadratic down there. So +4 and -1. This simplifies to
-2.
-2 or +2?
Oh, +2.
+2. Negative divided by a negative. So we have this x is equal to 2. This is known as the axis of symmetry. If you want to give it a name, it's a vertical line that the parabola reflects over.
Do you have to move that
Huh?
Memorize?
-b over 2a? Yeah, it's actually part of the quadratic formula if you think about it. If you get rid of the square root part, -b over 2a. All right, what do I do with x equals 2 when I find it?
Plug it back into it.
Plug it back into the function to find what y is equal to. So f of +2 is equal to negative something squared plus 4 times something minus 5. I hope you get into the habit of replacing letters with variables. A lot of you are making mistakes not doing that and coming up with some weird answers. What goes inside the parentheses? 2. Whatever. Is it -1? I don't know. This becomes the first piece here. What's this? -4 plus 8 minus -1. So f of 2 is -1. So that means my vertex has a coordinate of,
2,
I love function notation because the x coordinate is here and the y coordinate is on the other side. So you get 2, -1. There's your vertex. So I have my y-intercept. I found that there were absolutely no x-intercepts, but I did find a vertex. Okay. One, 2, 3, 4, 5. And just plot what you have. Highly suggest you put the axis of symmetry in first, because that gives you an idea that half the stuff has to happen on the left and half the stuff has to happen on the right. So the axis of symmetry here is x equals 2. How do I graph it?
2.
On the 2. And then what do I do with it?
Draw a little dot.
Just draw a dot?
Yeah, a little line up and down.
Oh, a vertical line going through. So there's your axis of symmetry. Okay. And then plot your points. What point goes on the axis of symmetry?
The vertex.
And vertex is at 2, -1. So 2, down 1. It's here. That's my vertex. Highly suggest you label your vertex. It's probably one of the more important points. The y-intercept is 0, -5. That's way down here. and I can find only one more point.
Other side of it.
Right. How far is it away from the axis of symmetry?
2.
2, so I would just have to go 2 more. So that brings me to this coordinate, which is 4, comma
4, 5.
4 positive 5
Negative 5.
or negative 5. And that becomes our reflected point. And then we get our parabola. It goes down through the y-intercept, and it goes down through the reflected point. And notice this graph has absolutely no chance of ever having x-intercepts. Because it's facing down. And that's easy.
Yeah, you get that one there from.
This point here, 4, negative 5.
Uh-huh.
Because the y-intercept, you always want to go to the axis of symmetry. That's 2 points, right? 2 units. So it's going to move 2 more units to the right. Because it's getting reflected. Remember, like a mirror? So how far it is away on the left is going to be the same far away on the right. That's that neat property of reflection.
If it was on that, if it was an X,
Intercept.
you said, then what? Like, how?
That vertex would have to move. To get that to have x-intercepts, the vertex has to go above the x-axis.
And then you would just reflect it.
Well, x-intercepts, you would find both of them. You don't have to reflect it.
Yeah, you would find both of them, and then you would reflect the.
Y-intercept. Any which way, I'm going to reflect that y-intercept. This way it becomes really important because I have no x-intercepts. So I have to use that reflection.
So you would have, if you would just have one X-intercept, right?
If it touched the x-axis, then the vertex and the x-intercept would be exactly the same.
Okay,
You see what I'm saying?
I think.
No x-intercept for those that come in late.
The train was stopped in the street.
Top of my head, man.
Well, that's low on the board.
Oh.
Alright. So that's graphing a parabola. Same steps all the time. X-intercepts, Y-intercepts, axis of symmetry, vertex. And it doesn't matter what kind of answers you get out of it, just accept them. If there's no x-intercepts, there's no x-intercepts. Don't force issues on this stuff. I've seen people force issues and the picture becomes some weird shape. Where the axis of symmetry is one place, the vertex is someplace else, the x-intercepts are not even separated by the axis of symmetry. Things have to happen in that kind of order. All right, word problems. Aren't you all excited?
The word problem every time.
Yeah, especially near the end of this stuff. Let's see. Do they have any good ones? I don't think they have very difficult ones. Oh, you liar. Boring, boring, boring. See, that's just boring questions. Maybe I won't do any word problems because they don't have any good ones. Oh, wait a minute. Let's do number 34. It's on page 462. This isn't really what I consider a word problem. It's a problem that has a bunch of words, but they give you the function. You don't have to design the function on your own. What I consider word problems are ones where you actually have to design the function and then solve it. This one's just asking you to solve it. So you have to read the very top of this. It says manufacturing profit. The daily profit P in dollars of the Pine Tree Table Company is described by the function P of X blah blah blah, where X is the number of tables manufactured in one day. Use this information for the exercises. So 36.
36, 34.
Did I say 30? 34. I said 34. 34. The function is this. P of X is equal to negative 6x squared plus 312x minus 3,672. Thank God for calculators. Because these numbers are kind of large. So this problem is asking how many tables per day should be sold, because X represents the number of tables per day that should be made, in order to obtain a daily profit of $330. Now, if I'm talking about a daily profit of $330, what value is that really? It's not X, because we're trying to find X. We're trying to find how many tables need to be sold. Well, it has to be the y. So what represents y in this case? Well, where's y in this function?
It'd be 0.
No. Where is y in this function?
It should equal to y.
What is y then?
P of X.
P of x. See, x is over here. This must be
Wow.
y. So this is telling you that y is equal to 330. So you have everything you need for this equation. You just have to plug in the information. So to solve for x here, we need to replace y with 330. So you take p of x, you replace it completely with 330, and it's going to equal negative 6x squared plus 312x minus 3,672. All of these problems, when you're dealing with functions, it's here's an x, find me a y. Here's a y, find me a x. And you just have to recognize that if this side has all the x's, the other side has to be y, guaranteed. How do I solve this equation?
Set to 0.
Get it equal to 0 first. So subtract 330 from both sides to get it equal to 0. So we get 0 is equal to negative 6x squared plus 312x minus 4,000?
4,002.
4,002. Okay. What should you try first before doing anything? Try pull out a greatest common factor. In other words, does 6 go into every number up here? If it does, that'd be wonderful. If it doesn't, at least 2 goes into it. I think 6 goes into it.
Yeah.
Yeah. So what we're going to do to the whole equation is divide everything by
6.
negative 6. Get rid of that negative 2. So divide everybody by negative 6. Make your numbers smaller. I know a lot of you would look at that and go, oh, let's just jump right into the quadratic formula. And what will happen is the numbers just get huge and it's unwieldy. But if you get rid of a factor of 6, things get a little smaller. Not hugely smaller, but a little smaller. So you get 0 equals,
Negative 52. X squared.
huh?
X squared.
X squared
Minus 52.
minus 52x
Plus 667.
plus 667.
Yeah.
Gosh, I wish there was factors of 667 that added up to 52. Anybody off the top of your head? Maybe? Not me either. So I highly suggest at this point quadratic formula. So if you're going to plug this into the quadratic formula, all this. Let's see, this becomes negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. And this is going to equal the x that we're looking for. Okay. B? No, negative 52. And negative 52 also goes in here. A, positive 1. C, 667. And then A, ooh, I did it again. I always do this. I really need to put parentheses here. And what's A? 1. Simplify it a little bit. So this is x equals positive 52 plus or minus the square root of, type in what's underneath the square root into your calculator. Just the underneath the square root. Don't include the square root. Wish I had my calculator.
36.
Really? Yeah, that's pretty cool.
36.
Little chorus going on there. All over 2. So this does factor. It's just I didn't want to go searching for factors of 667. Square root of 36 is plain old 6. So you get x equals 52 plus or minus 6, all divided by 2. You have 2 choices. You could do 52 plus 6 divided by 2, or you could divide everybody by 2 and then do the plus or minus. It doesn't matter. What's 56 plus 6?
56 plus 6 is 62. 52 plus 6 is 58.
What did I say?
You said 56 plus 6.
50. No, be quiet. 52 plus 6. 58 divided by 2. 29. And if we do the other one, it would be 52 minus 6,
46.
46, divided by 2,
23.
23. So there's two possible answers. We get x is equal to 29, or x is equal to 23. So what is this telling me? Well, to make this profit of $330, they can either make 29 things, or they can make 33. Both of them make sense. Why are we getting two answers? Why are we getting two answers?
Because
What's the graph of the black thing up here look like, P of x? It's a parabola, right? Which way is it facing?
Up.
Really? Down. Because of the negative, it's going to force everything to become negative. So the graph of this thing looks something like, it's not a very good graph. Let's see.
Would those be the x-axis?
It would start down here someplace, it would come up and then go back down. It would come up and go back down. I guess if you don't make too many chairs, you're going to lose money and you have negative profit, which would be you're in debt. Eventually you will break even. That's when you cross the x-axis. You're not making a profit, but you're also not losing any money. And what's happening here is this 330 the vertex of this parabola?
yes.
No. Because the vertex will only happen how many times? Once. This point is happening twice. So more than likely, 330 is here.
But how do you make 330 up two different numbers? Either
It's not
23
that I'm making 330 two different numbers. I'm saying I can make that profit by making 29 chairs or 23
But if you
chairs.
hit 23 and you're making 330, then everything over that is just extra profit, right?
Between them, yeah. See, 330 will hit here, and here's one of your coordinates, and this would be your 23. And here's the other coordinate, and this would be your 29. So what do most manufacturers want to do? Do they just want to reach a certain profit? What do they want to do with their profit?
As much as they can.
They want to get out of it as much as they can. Really what they're going to be looking for is this point up here, which is called the vertex. How do you find the vertex? You go back to the original function, negative b over 2a, and you can actually find what number of chairs is going to maximize your profit. That's actually question number 33. And you'll find that the maximum profit is much bigger than 330. It's just the property of parabolas. It only has one solution at the vertex. Everything else has two because of that property of the reflection. Yay!